Good morning, everyone, and welcome to our third webinar for this year. We will explore the power of SOLIDWORKS Electrical. So on the agenda today, we will be covering the following, which is SOLIDWORKS Electrical. What is SOLIDWORKS Electrical and why SOLIDWORKS Electrical? We'll also look at the electrical portfolio that's within SOLIDWORKS. We will just see some benefits with the portfolio and the benefits of using SOLIDWORKS Electrical in your organization. And lastly, Warren will do an electrical demo, just showcasing the synchronization and also the collaboration between electrical 2D schematic as well as the 3D component of SOLIDWORKS Electrical. So just your host this morning. So my name is Jean Henry, and I am an application engineer here at MECAD Systems. I boast a mechanical engineering diploma in mechatronics, and some of my certifications that I've acquired here at MECAD Systems or through SOLIDWORKS Dassault Systems, is the mechanical design expert, my certified SOLIDWORKS professional simulation, as well as my certified SOLIDWORKS associate electrical. And currently my key focuses within MECAD is electrical, 3D CAD design, as well as simulation. So I'll just hand over to Warren, who will introduce himself.
Good morning. I am Warren Asia. My profession, similar to Jean, is application engineer as well. My qualification is a Bachelor's of Technology in Mechanical Engineering, Mechatronics. And then some of these certificates attained is a certificate for SOLIDWORKS Expert in Mechanical Design and Certified SOLIDWORKS Associate in Electrical. I also have some key certifications in CAD rendering and some simulation as well. So my key focuses are in electrical, 3D CAD design, and CAD rendering. Thank you very much.
Thank you, Warren. So what is SOLIDWORKS Electrical? SOLIDWORKS Electrical is a computer-aided engineering design tool within the SOLIDWORKS design, which offers the following. It helps design engineers mitigate risks and accelerate product development. It reduces the need for physical prototyping, resulting in cost and time saving. It also offers a comprehensive set of electrical design capabilities. It enables integrated design early in the process, reducing potential defects. And lastly, it minimizes the costly design rework, saving time and money. So why SOLIDWORKS Electrical? SOLIDWORKS Electrical helps companies simplify the electrical design process and enables concurrent development of electrical and mechanical aspects of a design. SOLIDWORKS Electrical is unique in its ability to provide a real-time bi-directional link between SOLIDWORKS Electrical schematics as well as the 3D mechanical models. And this offers a clear advantage to any company where two or more users must collaborate on a project, and having up-to-date and synchronized information is a must. And we all know how important it is to have a collaboration between different departments. If you are a turnkey company where you're doing mechanical, electrical, automation projects, you need a collaboration between all three departments. And that's why it's very important that we have this collaboration, and we're all looking for a product that can provide this. And some of the capabilities of SOLIDWORKS Electrical. So SOLIDWORKS Electrical schematics are bidirectionally linked to allow multi-users interaction in real time. They're also linked to your 3D SOLIDWORKS assembly, facilitating verification of a proper fit, planning of all wire cable and harness routes, and calculation of wire lengths prior to assembly. So working with ECAD and MECAD together ensures consistency and facilitates the creation of your bill of materials. And some component databases is easily linked to the MRP and ERP. So if you do have a MRP or ERP system integrated or implemented in your company, it works well, and it can also easily be linked to supply info, lead time, and other relevant data is captured at the time of design. SOLIDWORKS Electrical also translates single-line schematics into detailed multi-line power and control and PLC schematics. And also SOLIDWORKS Electrical offers a detailed terminal strip management tool, which is actually one of the nice features in SOLIDWORKS Electrical. And SOLIDWORKS Electrical, lastly, allows for the reuse of existing designs. So no more do you have to redesign, for example, a direct online. You don't have to continually start each and every component. It's just a matter of creating macros of a circuit and just copying and reusing that information. So what are the benefits of SOLIDWORKS Electrical as a whole? Firstly, you can streamline the development process. Secondly, you can avoid hidden costs. Thirdly, you can reduce manufacturing defects. And lastly, you can also avoid the time to market delays. So I'm just going to go through the portfolio of SOLIDWORKS Electrical. It's a vast portfolio. So we're going to look at it with a schematic, the SOLIDWORKS schematic product within the portfolio. So the schematic is broken up into your standard package as well as your professional package. So the schematic standard offers a subset of the features of schematic professional. So for those not needing the full feature set, so if you don't require the full feature set of the professional, you can opt for the schematic standard. SOLIDWORKS Electrical Schematic Professional is a powerful, easy-to-use schematic design tool for the rapid development of embedded electrical systems. So for equipment and other products, it features built-in and web-enabled libraries of symbols and manufacturing part information to streamline the design process. So with these automated design and management tools, users can simplify an array of tedious design tasks, from terminal blocks to contact us reference assignments. So you can see in the tables, the two tables below, so you'll see that schematic standard offers anything between single line schematics up to report generation, whereas the professional includes all the schematic standard tools, as well as additional tools or functions that you can use in your in your design process or in your business. So one of the nice tools in this portfolio is, which I personally like, is the content, SOLIDWORKS Electrical content portal. So on that portal, you find manufacturers around the world. So example, your ABBs, your Schneiders, your Wade Mullers, etc. So you can find all your schematic, your 2D footprints, which are your symbols. As well as your 3D components. You can find the manufacturing parts of that. So if you have a circuit and you want to insert a manufacturing part for that symbol, you can just assign a manufacturer to that, and it will bring through all the information onto that symbol. Another product within the portfolio is the 3D, electrical 3D, which Warren will go through later. And with the solution offers or allows, for the integration of electrical schematic design data with the SOLIDWORKS 3D model of a machine or other product bidirectionally and in real time. So SOLIDWORKS 3D electrical 3D, enables users to place electrical components and use advanced SOLIDWORKS routing technology to automatically interconnect electrical design elements within the 3D model. So users can also determine optimal lengths for wires, cables, and harnesses, all while maintaining design synchronization between schematic and 3D. So for example, what they're explaining over here is, or what is being discussed here is that if you're designing your model in 3D and you send one of your technicians to site to measure the cable route, for example, and he comes back and he gives you that information that the length of the cable for maybe 250 millimeter squared single core cable is 1 kilometer or 1.5 kilometers. We can import that information in the 3D and it will automatically sync to the 2D schematic, where it will populate specific properties. And when you generate your bill of materials, for example, it will populate those lengths in there. So there's gone are the days where you have to you have multiple spreadsheets open and typing the same information 3 times, 4 times over. So electrical 3D, so with this, the schematic design data from SOLIDWORKS electrical schematics are bidirectionally integrated with the SOLIDWORKS 3D CAD model. It also offers real-time synchronization. So the synchronized bidirectional environment enables multiple users to work on the same project simultaneously and in real time for easier project collaboration. We also have an auto routing tool. So this is advanced SOLIDWORKS routing technology, simplifies the auto routing process for wire, cables and harnesses in the 3D CAD model. You can also create harnesses as well, harness developments. So this creates schematic-driven harness designs utilizing real-time bi-directional functionality coupled with powerful routing and flattening and automatic documentation. And also all project design data are bi-directionally synchronized in real time between schematics and the electrical and 3D model in a multi-user collaborative environment. And lastly, extensive integrated library of manufactured parts provides an easily customizable and also adaptable part base through easy to use import tools and wizards. So you will see this image here of the control panel over there. So basically you have a 2D schematic and you can actually create a 3D model of the schematic using the 3D electrical product. Another product within the portfolio is Electrical Professional. So this is a mixture of, or a combination of both the schematic and the 3D. And you'll see these are just some of the tools or the functions within Electrical Professional. As you can see, they range anywhere between single line schematics, which is your which is your standard and part of your electrical schematic professional package. And it goes all the way through to your 3D electrical components as well. And another tool, another product within the library is what we call the Electrical Schematic Designer. And this is a purpose-built, easy-to-use, intelligent 2D electrical design and documentation solution. So smart electrical designs and documentation functionality, speed, design with improved accuracy, and leveraging the secure cloud-based technology of the 3D Experience platform to store, manage, and collaborate on electrical and mechanical product designs, and all fully integrated with other SOLIDWORKS solutions. So if you are using 3D Experience in a cloud-based product of Dassault Systems, you can also work with 3D with the electrical schematic designer. So, and also with the design automation, this accelerates the electrical design process with intelligent and automated design documentation and reporting capabilities. And also electrical design features speed tedious tasks compared to traditional CAD tools. Another cool thing about this schematic designer is the collaboration aspect, and this improves the product team efficiency and communication using secure cloud-based communities and data management to connect all project stakeholders and share relevant information from a single source of truth. And lastly, we have the integration, which is a fully integrated electrical and mechanical design using all 3D Experience SOLIDWORKS solutions to speed up overall product development, improve your quality, and also simplify support in one common environment. So I'll just, Warren will take over and he will just actually showcase the synchronization between the 2D schematic as well as the 3D electrical as well. And we can just, like I said, if you have any questions, you can just ask in the chat and we will answer as we go along. Thank you. Thanks, Warren.
Thank you very much, John. I will go over the next portion, which will basically show you a demonstration of the collaboration between the two, the schematic side and the SOLIDWORKS Electrical 3D side, and how both can come together and create something that you want in your workplace or your desire. So firstly, here we have an assembly. This is an assembly of a packaging layout. So our focus is going to be on a subset of this specific layout. So we're going to target this area over here. So over here, we have a cabinet, the electrical cabinet that we're going to focus on. We want to create our wires and cable routes to this cabinet from the schematic and get those lengths, as Jean said earlier. So we're going to first notice that on the right, this is a project. And in a project, you can have multiple document types like this one, the data sheet, which can explain that specific data sheet for that component. And here we can see the diagrams used inside from the schematic, even on the 3D side. Here is the layout, and here's our locations we just saw. Locations are not just locations in SOLIDWORKS Electrical. they also correlate to the schematic and where the route will go towards. This is the diagram for our layout, and our objective is to add a fifth motor that will connect to the terminal strip for X1, which will connect to the contactor and the breaker for Q4, and they will also give power to the PLC by using the breaker and the transformer. So those are the things we need to add. We'll go ahead and add the electrical sub-assembly by opening it. We have a half-ready electrical cabinet already. We're going to add the rest of the components. Then over here, we also have the motor that will be added. We can just simply add that component by using functions like mating. And we're going to actually create the fifth motor component that will be added to our schematic and then assign it. So now I'm opening my schematic, and what immediately you'll notice is that this file is actually opened already in the 3D side by another user. It is myself, but it means that the same project is opened already. That's not a problem. It's just notifying you that because many people, even from different departments, can work on the same project at the same time, allowing for a streamlined project in a company. So now we're going to go ahead and open the diagram where we will continue to work. So we're going to address that specific motor. So we can just take away this markup over here that says to add the motor, and then we can just add the symbol for the motor. Immediately you'll notice that it's using the last used symbol, and that is this push button over here. We can just go and choose the classification for the motor and select the motor we want to add and click to add it. The information here pops up to tell us that the symbol properties we are about to add correlate to these information. Immediately the system picks up and tells us the next number for the motor to add is number 5 because we already have 4 in the system. So the system knows that all we need to do is add a short description now maybe to just give what this is. So just motor should be sufficient for this diagram, and we can then specify the location of where it needs to be. And there we can see the rest of the components in the other conveyor's location, and there we go. We can go ahead and draw the cable that will connect this motor to the terminal strip, and that should be good enough. We can go ahead to the power schematic now, and immediately you'll notice motors 1 to 4 is on this power schematic. Our job is to replicate 1 to 3 for the number 5, for motor number 5. We can simply click and drag this and copy, but for this case, we want to do a more manual process to show you exactly how the setup was done. You can go ahead and draw wires using SOLIDWORKS Electrical Schematic, and these wires can be in single wires or multi-wires. But I'm going to chat more about wires and lines and the difference between the two as well. So we can just go ahead and click and drag and then pin it close to the motor on the top. There we go. So now lines, as I've said, are not just wires or lines. These lines are actually intelligent. If you click and copy and paste, it connects on the right-hand side over there. So it also splits this one line that was 1 into 2. Similarly, if I click and drag it now to the top, it also splits this 1 into 2. And if I click and drag and put it onto the 1, it merges it now together. So what it actually, and it also healed the one on the right-hand side. What this actually means is that I want you to understand there's 2 different depictions of this line. It's the graphical and the electrical attributes. The graphical is what controls the orientation and what you see on the page in a more graphical way, how they look for the orientation or their thickness graphically. But then you also get the electrical attributes that define exactly what they are. What I wanted to explain about this as well is that the system works based on anything that you input in the schematic. So anything that you update or reflect in the schematic will all be live, and any other person that works in the same project will also see the information that also updates here. So anything that are changes or added or anything like that can all be done live, and any other person working on the same project that has it open at the same time will see that information updated. Just going to go ahead and draw those same wires there. So these wires also, I want to specify the differences. So graphically looking at a line, graphically you'll see there's different thicknesses, and the wire can appear to be a certain thickness, or there can be a certain orientation. But then you have the electrical attributes. That can be a specific equipotential as well. So think of a line as not just the wire. On the right-hand side, as I've said before, they can also merge onto one, and they can also connect to each other. So as I do it there on the top, they also connect to the one, and they actually break the other. So it also merges together as well. And because they have different equipotential, it means that the software is actually capable of being intelligent and allow you not to make little mistakes that are electrically not correct. So you can go ahead and create the next symbol, which is the motor, which is that motor number. So as I've said, it's actually electrically intelligent. So the software will stop you and tell you if you're making a mistake. Right now, we're actually connecting that motor M5 we just now added to that specific diagram that we just saw for the motor that we just added. So we're connecting it to that motor 5 diagram. The description also picks up. And here in our manufacturer part circuits, the symbol has a requirement for 4 circuits. That's the 3 motor and the ground that you see there at the bottom. So you need to select a manufacturer part that will actually allow that to be electrically correct. So you can go ahead and just search for it. And it also picks up the last used manufacturer part. This Leroy Sommer was the last used, but you can also search for a reference. And here's different categories that for manufacturer parts that are in our system. We can search for a reference. From the elements for 139, we can search LS, and it'll change to 66. And we are looking for the asynchronous brake motor over there. So we're going to use that one, and we can just simply add it, and the circuits are also electrically correct for the required circuits of the symbol. So you can just go ahead and add that, select, and say okay here, and it also picks up the metadata of that specific symbol for the motor. So here it'll also tell you, okay, the diagram is correct, and it lines up with the symbol on the schematic. Furthermore, you'll also see that motor 5 got added as well. So it's now updated and reflected on the 3D side. It's not assigned yet because now we need to assign it to the 3D CAD file, which is this file over here. And there we go. It's now assigned to that motor 5. We can now go ahead to the next portion. First, we need to go ahead and add the symbol. So now we can look through all the symbols in our system. But if you don't want to do that, you can create something like a palette to search for symbols based on what you have. So you can search a description like 3-pole, for example. It'll bring up anything with a title called 3-pole. And you can just click and drag and put it into your schematic, and it'll connect all the lines just as you've added them, just like that. So you can connect it up just like that. So now that it's connected, we actually want to connect it to the Q mark that we already have in our system. So we're going to just give the root Q and assign it to the already one that's existing, number 4, and just say, okay, so it assigns to the diagrams breaker. So now we can go and do the contactor. You can just copy and paste this guy over here, paste it, and we can edit the symbol properties for the contactor and assign it to the correct contactor in the diagram, which should be number 4, connect to it and associate it. The data populates just like that. So now we need to do the terminal strip. So the terminal strip is what connects the terminal strip to the motor over there. That wires are connected over there, similarly on the right over there. So these are going to be done using the insert in terminals command. You can click and drag over there and then choose the direction. And here the system will tell you there are the available terminal strips and also the next number that it will jump towards. So there is 21 onwards, and now we can edit this terminal strip. So furthermore, you can see the cable cores have been assigned here to the ones on the top for the other motors, but not the one that we just now added. The part has not even been assigned for the one that we just added. These are the motors number 5 we just added. And here we need to assign for the terminals from the 4. So we're going to go and multi-select and assign the terminals to add for those. We can go ahead and search from the last used one. It's the 2 conductor 2 terminal block. Add it, and there we go. It's going to be a different type for the earth one. You can go ahead and select 2 conductor earth terminal, select, and there we go. So now we've added the terminals, right? But now that's the physical part. We need to now assign the cable cores to those different ones from the motor. So you can go ahead and assign cable cores, choose the location because it's in location of other conveyors, select, and then we can go ahead and look for the cable that we have available. So you can see that cable number 9 is already used because you can see the destination and the origin. Origin is X1 and destination is M4, meaning that's connected already to motor 4. Number 10, however, is available, so we can use this and associate those cable cores to the ones that are required for this motor. There we go, associated. So now they're connected up, perfect and ready. The program now knows where it needs to go. You can also generate a drawing of this terminal strip very easily. So we can just say generate, and it generated the drawing of the connection of those terminal strips. So we can go ahead and look at the drawing. Here it is. So this is the drawing of the terminal strip layout to all the 5 motors. Can you imagine doing this manually, line to line, cable to cable, and drawing to drawing? It'll take you so long using stuff like erase, move, cut, paste. It'll take too long. So everything is streamlined to allow you to do everything you need to do so much faster. Our next job is to tackle the power to the PLC. So we need to add the power here, but we already have a similar circuit in our project, and that is coming from the pallet dispenser, right? So we can just copy this information and put it on something called a macro. On SOLIDWORKS Electrical Schematic, you can store circuits and represent them at an application level and to be saved and used by anyone else in your company or even reused for yourself. In our case, that'll save us time, whether it was a shorter circuit or a larger one. And click and drag it into the macro palette and just save it as a name, whatever the case may be. We can then move back to where we want to actually add this macro, and which will be in the power packaging line. So you can click and drag and just place it, and it will automatically connect to the wires needed on this for this schematic, for this circuit. So then you can just go ahead and assign the number for the value in the diagram, which is number 6. Similarly to the transformer on the diagram, which is only one over there, and it's connected. So now we need to actually connect where this transformer is giving power towards, which is the PLC on the right end. So now you need to connect that neutral and that live. So we use this with managing destination arrows, origin and destination arrows. You can use insert single insertion, and from one drawing on the left to the next drawing on the right, you can simply click and click to tell where that line is going towards on the next page or diagram or schematic. So in our case, we're going from this neutral to the next. However, as you see, as I move, you cannot go and place a different equipotential on a different wire. It's impossible. The system will not allow you to do that. So it's intelligent in the way that you will only be able to connect the same equipotential wires. So you can place that over there and do it for the live on the other end. And there we go. Now I can go back to my schematic over there, and I can go and use functions like go to, which will allow me to go to that specific page and number. So I can right click here and go to, and it'll tell you where I'm going to, which is the neutral on this PLC over here. So I can go ahead and follow the trail and go to, once again, on this side, and then go on to the next side, which is this PLC line 2. Immediately, you'll notice here for the contactor K1, here is the cross-referencing to show you what circuits are available, the available circuits and the one that is available, the ones that are used and one that are available. You can also double check it here by the circuit states here on the manufacturer part, the ones that are available, the not normally open contact is still available. So now we can go ahead and move on to our next portion, which is the reports. You can just check here under the reports, the length of the cables are not updated, especially for the number 4. You have a list of cable cores that we will get information of from the report. And the cable is actually the one for number 5 that we will address. So let us number these wires, and then numbering the wires will just quickly allow you to number all of them so the system can actually detect which number and also update the report for all those wires. Okay, so now we're ready to move to the 3D section, where we can now, based on the schematics information, move on to what is required changes on the 3D side. So here's our motor once again. It's been assigned. Let's look at the cabinet a bit more closer. So here's our component that's already assigned. We need to add the terminal strip that we created for the connection of the motor. It's X1. So there's no terminal strip at the moment. We're going to connect all of them. So you can just use insert terminals. To click, you just put it on the rail, just like that. And you also have functionality to add to this, either the left or right side. You can specify spacing and then just say, okay. What this is now doing is it's actually creating an assembly in the background and creating and adding it to your assembly for your project. So it's building it on the fly and adding it just like that. Okay, next we need to then hide what's already inserted, and then you will be able to quickly see what you need to still do. You can multi-select those components, and we're just going to move this into the middle. And what this will allow is you to multi-insert components from your schematic that you assigned as manufacturer parts into your 3D CAD model so that they fall in line one after the other in this order. You can also, like the terminal strip, specify the grouping, the spacing, and what component comes first. So they also have smart mates, and that's because of SOLIDWORKS intelligent software to allow you to create smart mates. You can specify spacing, and it's now building this based on those specifications for the spacing of 12.7 millimeters apart. And it's putting it all on that DIN rail over there. So just like that, it created it for us. And it actually created in the background mates to that DIN rail. But not also that, it can still move on the DIN rail horizontally. Okay, so what's next is we need to attach the light for representing this specific component over there. So it's from the door location. That's H5. You can just go ahead and insert, and you can see it wants to add it, and you can just press tab to then switch to the other side and add the mate. So what's interesting is the library, this is actually a library feature, and it uses smart features. It allows you to, with that placement of that part, automatically create a cut on this face. So because I just inserted it there, it created this cut. And if you open this, you can see that the cut is automatically created there based on where you placed that light. So you don't need to go and create sketch, extrude cuts, etc. Everything is it's made for you to streamline productivity. So what's next? We need to now go and address the wires. We can now go ahead and route the wires based on the distance between wires and routes, use the 3D sketch route and splines, and start the route. It's as simple as that. Based on the specifications for distances between wires, how you created the splines, or even how the distance of the components are for the route, will develop an algorithm based on how the route should take into the ducts and through your components. If, although you specified, for example, that in the schematic, the wire should have a fixed length, you'll either get an error to tell you that the system cannot create the route for that wire because of the fixed length, or it'll create it, but it will go through components and give you undesirable results. So if at most case, I would suggest always go with the SOLIDWORKS route, and then you can grab that information from the route and fit it into your bill of materials for the lengths of those wires and those cables. So there we go, wires neatly represented. Let's just view this much more closer. And then you can see it routed the wires very neatly based on those splines. So now we need to address the cables. And it also, additional to this, you can also choose to do lines. I forgot to mention that one. You can also route by lines. It would look a bit cleaner, but you wouldn't get these spliny edges for the lines to route towards. So I like the portion with the splines. So we need to go ahead and do the cable. So the cable is going to connect to this motor. You're going to use the SOLIDWORKS route. Why? Because the SOLIDWORKS route will give you a 3D CAD routing file so that it looks 3D. And then this specific component, which is M5's motor, and based on those settings for the routing parameters, we'll just route this cable. Now, it's actually going to route the cable from the electrical cabinet to this motor. But how does SOLIDWORKS know where to route or how to route? Because there are ducts there at the bottom, right? To route through. That's your desirable route. And how the program knows this is you give an input based on a path sketch or a routing path sketch. There we go. The route just finished with the cable. So let's zoom out a bit. So here is the route it took. And the reason why I did this is based on this sketch, EW path. This is the path that you told the route to take. So it'll take this path based on the sketch that you created. So if you specified it to be in the duct or go through this specific duct, it'll route through that path. You also get features like segregation on top that can allow you to segregate through ducts that you don't want your wire or cable to route through. For example, you might want a higher power cable or wire to pass through a specific duct or be closer to a component from the door. You could also segregate certain components and wires through the ducts. Here is the cable that are connected to the terminal strips. There we go. So now we can go ahead and look at the report. The report updated for the length of the cable. There we go. And then here is the list of cables that were updated over here. And there's the bill of materials, but there's the list of cable tags, the bill of materials over here. And then we're going to add one more, which is the wire line type. Over there, the wire line type updated with the lengths of those wires. And then we can now go on and move over to the next section, which we want to go ahead and talk more about or go over the drawing generation. So now that all of this is created, we can now display this into our project folder. And let's say the project folder is maybe in a PDM vault, and you had the vault given access to certain members from electrical department or both electrical and mechanical department. You can update those in that folder. So we're going to view the sketches in here and create 2D drawings. This will allow us to create the 2D drawings of our assembly. So they are our parts over there. Everything just now got updated and rebuilt in the background. So you can go ahead and go to the sketches and just view them so that they show in the drawing with their colors if you were to print it in color. And there we go. So you can also generate a drawing of this. And what this is doing is generating the drawing of this into the project with the bill of materials. You can go ahead and generate this, and it will add it to the project that is in the specified folder, right? So with this, you can also create multiple sheets and export them at the same time as well into your project folder. No need to do anything manually or click and drag, it's all automated. So now we can go ahead and check the location. So let's say the location was in that vault. We're just going to access that vault. And let's say it's in the electrical projects. So in the electrical projects folder, we want to store all the information. It's already been assigned a location. All you can need to do is update the PDM data files, and it exports all your files, all your CAD files, all your data specification sheets, all your drawings, all your reports for the bill of materials, those cable lengths, wires, etc. They're all getting exported to the folder. And what's great about it is about PDF is that you can also get the history from the file if it were changed in any way and by who it was changed. You do it the very same way, update those data files. And with the files, you can see anyone who's worked on it, when they've worked on it, and what it currently looks like, if it's up to date with the preview, etc. So it's very ideal for a PDM system. And just like that, it generated all the drawings into the projects folder in the vault. There's the CAD files. You can just check this by using the preview. And just to see the preview updates, there we go. Here is the terminal strip drawing, and there we go, updated as well. And you can see the history of it as well. And you can check the reports done for those cables, lengths, wires, etc. This can be exported to an Excel as well. And here is the drawings of all the documents in the project. Their references, from to connections, locations, setup for the diagrams and schematic as well. So thank you very much. I really appreciate the time there. I hope that was very engaging to understand how the product works together. What I do want to show you as well as earlier, Jean mentioned about the different products. And I also wanted to let you know that SolidWorks, the SolidWorks Premium, also allows you to use routing capabilities. It allows you to use it for electrical as well. So if your interest is electrical routing specifically, and you want to know more about the difference between the two, what this product can give and what SolidWorks Premium routing can give because it's a bit cheaper, you can also go ahead and see that I have that as well as a link that you can see. I'm just going to go to it. It is over here. So you can open your phones and take a look at this QR code. This QR code will reference you to a link to find out the differences between the two. I have created the article through the link, and it will just tell you about the difference between what we just demonstrated to you and what the SolidWorks Premium's routing electrical is. And maybe that'll gauge a better understanding about what product is better for you and what you want to do.